Hello class. Today we are going to talk about the area of sectors. So, of course, that begs the question, what's a sector? A sector is a region of a circle that is bounded by a central angle and its intercepted arc, like this. So here we have circle A. The central angle, that's what I got here in blue, angle CAB, or you could call it BAC, that'd be fine. And the intercepted arc is this orange arc right there, arc BC. And the sector is what I have highlighted in pink. This is sector CAB, and that's how you name it, with all three letters, just like naming the angle. And we don't have a symbol for sectors, so we just write out the word sector, sector CAB. We could also call it sector BAC. That would be fine. All right. And so now what we're going to do in this lesson is we're going to look at how to find the area of this sector. So here we go. The area of a circle, you'll remember, is pi r squared, right? You all know that. You've had it for a while. So if I wanted to find the area of circle A here, well, I need the radius. The radius is 10, so I'm just going to plug that in. So pi times 10 squared, which would be 100 pi. If you want exact answers, if you want it rounded off, it would be 314.15, right? Approximately, because that's rounded off, because pi goes on forever, so we got to round it. Not exact answers. So if your teacher wants exact answers, it's going to look something like this with pi in it. If not, round it off to however many decimals it wants it rounded to. Now, let's take a look at this. If the angle here, the central angle, was, let's pick something easy, let's say 180. If this was 180, then I'd be looking at a half circle, right? So if I wanted the area of a half circle with 180 degrees, well, then I'm just going to take my area of the circle and divide it by 2, right? Times 1/2. So the area would be 1/2 of 100 pi, which would be 50 pi. Again, exact answers. Or approximately 157.08. Okay, but what if it was 90? What if this, because this clearly isn't a semicircle, it's not 180, but if this was 90, right? Okay, so let's see here. So the angle is 90 degrees. Well, 90 degrees, that's just 1/4 of a circle, right? So all we do is our area is going to be 1/4 times the area of the circle. So 25 pi, or approximately 78.54. Okay, so let's see here. We're looking for patterns so we can figure this out. Do another one. Let's do 60 degrees. Okay, well, let's see here. 60 would be 1/6 of a circle, right? So if it's 1/6 of a circle, then we can do 1/6 times 100 pi, the area of the circle, gives me 50/3 pi. If you want it in fraction form, so it's an exact answer, or approximately 52.36. Okay, so what would I do, though, if it was 124 degrees? Any idea what would do that? I don't know. Well, in all of these other ones, we said, well, this is a fraction of a circle, so we're just going to multiply it by whatever fraction is. Take the circle times some fraction. So we got to figure out what fraction of a circle is 124 degrees. Well, the entire circle is 360 degrees, right? So all we have to do is put this 124 over 360, and we end up with this. So we have 124 degrees over 360 degrees, that's our fraction, times the area of the circle. Goes like this. Notice you can put the pi up in the numerator, so 310 pi over 9, that's fine. It's just same thing here. Either way, whether you have the pi outside the fraction or in the numerator, either way is good. All right, or approximately 108.21. All right. So we see from this, we have our formula. And our formula for the area of a circle is going to be the angle, the measure of that central angle, over 360 times pi r squared, which is the area of the circle, pi r squared. That's where this 100 pi came from. All right? So that's not too bad. We're just taking the area of a circle and we multiply it by a fraction, and we get the fraction from the central angle for our sector. So here we go. Let's do this one. the area of circle C is 65 centimeters squared. We want to find the area of sector ACB. And so we don't have a radius, do we? Our formula clearly says we need the radius, right? And this did not give us the radius. That's okay. There's another formula that works. The other thing we can do with this is we can treat this like a proportion. Right? And so what that proportion is, the area of the sector over the area of the circle is equal to the degrees for the sector over the degrees of the entire circle. All right? So it's part over whole equals part over whole. So we are looking for the area of the sector. So let's see, let's set this up as a proportion because I don't have the radius, but I do have the area of the entire circle. So we are going to set this up as a proportion. So let's see, what is going to go here? We want area of the sector over area of the entire circle. Well, I don't know the area of the sector. That's what I'm looking for. But I do know the entire circle is 65. So I'm just going to use a variable for the sector. I'm just going to use S for sector. And 65 is the area of the circle. And that is going to be equal to the degrees of the sector over the entire degrees of the circle, 360. So the degrees of the sector is right here, 167 degrees. And so we have 167 degrees over 360. And then we solve a proportion, which is cross products, right? Little butterfly method there. So we have 65 times 167 equals 360 times S. Stick this in our calculator, multiply that out. We have 10,855 equals 360S. Divide by 360, and we get S is 30, approximately, this is rounded, 30.15 centimeters squared. So there it is. Another way we can do it. So let's take a look at a couple examples here. We want to find the area of sector XZY. Let's see here. We had two formulas. Let's put those right there. There are two formulas. And which formula are we going to use? Well, let's see. It did not tell me the area of the circle, did it? But it did give me the radius, so I can find that. So this one here, this one uses radius, so let's just use this. We have the area of the circle equals my central angle over 360 times pi times the radius squared. So my central angle is right here, that's 46, and my radius is 20. So we just plug those in, and we have our equation right there. And so now I am just going to get my calculator up. All right, so I've got my calculator, and let's plug this in. So we have 46 over 360 times pi times 20 squared. And we get that, 160.67 and stuff, so 57. So we'll round that off. We will use this abbreviated, and there it is. Area is approximately 160.57 inches squared. Right? So not too bad. All right, let's do one more example. Let's see. Find the area of the shaded sector if the area of if the area of circle Z is 162 yards squared. 62 square yards. Let's get our two formulas up there. So which one are we going to use this time? Let's see. We don't have the radius, do we? So we can't use this. But we do have the area of the circle. So area of the circle is right there. So we're going to be using a proportion. So let's fill this in. Let's see. I need the area of the area of the sector over the area of the circle. So I know the circle is 162 square yards, and the sector is what I'm looking for. So S over 162. And then I want the degrees over the degrees of the entire circle. So the central angle is not 53 degrees. I want the shaded sector. So how am I going to find the angle for the shaded sector? Well, the whole circle is 360, so we can just take this part that I don't want out, and that will give me my answer. So 360 minus the 53 that I don't want is going to give me 307 degrees. So 307 degrees over 360 degrees. Now I do my cross products, and I have 162 times 307 equals 360 times S. Stick that in a calculator. I come up with 49,734 equals 360S. Divide by 360, and the area of my sector is approximately 138.15 square yards. All right, so not too bad. Remember, a sector, it's just part of the circle. It does have to come off of the central angle. And also remember, you do have two formulas. Okay, one of them, the proportion, if it gives you the area of the circle, use the proportion. All right. If it gives you the radius of the circle, then you're going to be using this formula right here. All right. All right. So, hopefully you found that useful, and I will see you in the next video.